Welcome to this workshop, and thank you for signing up, for your interest. Thank you to everyone at Core Studio for organizing the event. It's going really well so far, I think, and it's really nice to be able to share with you what we're working on and all these tools, and also to discuss and brainstorm about where to take things further. So the final title I picked for this workshop is Automate and Collaborate with the new Shapediver clients. So I don't know how many of you are already familiar with Shapediver, but what we'll see today are very new things that stemmed partly because of new features of Shapediver, and in a big part also because of we got closer with Core Studio and with the Swarm tool that they had created a prototype of. So that's what we're gonna look at today. So we'll start with like a quick overview of what Shapediver is, and especially in its new iteration. And then we'll focus on the Rhino client, which we'll have a live demo of today, but we'll also talk about further clients that are coming up, and finish with a quick overview of what's next, what we are working on, and how these new tools will be applied in the future. I added Q&A as a last step, but I urge you to stop me anytime you want, and we can have quick chats about any topic when I talk about them. I think it's more productive like this. And yesterday, no one interrupted me, so I'm not afraid that this will happen too much, right? So please, if you have a question or something to ask during the presentation, you can. But overall, if you have technical problems during the presentation using the Rhino clients that I sent a link for in the email, you can ask Emil and Sergey in the chat. Hopefully that should solve all issues. The main issue we had yesterday was people not unblocking the archive before unzipping it and installing the plugin. So make sure you do that, and make sure you have Rhino 7 as well. Yeah, that's it. If there's questions you think will be interesting for everyone and not just a quick, because I won't be able to follow the chat, so you can also use the Q&A. There's a Q&A interface where you can ask questions, and those ones I'll be able to easily check and answer either during or at the end of the session. I think that's it for the introduction. So let's get started. So Shapediver 2.0. So I don't know, again, how many of you are really familiar with what Shapediver is so far, but essentially the Shapediver platform was built as a scalable, secure, and reliable infrastructure to upload parametric designs in the cloud. So in particular, Grasshopper definitions, but the infrastructure is built to be compatible with other parametric workflows. And once they're in the cloud, to access and be able to interact with these remote algorithms, essentially, through various interfaces. Up until today, like the legacy platform as it exists today, the two main ways to interact with it are through a web browser. So you can sign up to our platform, and you have a 3D interface, and all the parameters that are exposed in the Grasshopper definition can be interacted with, and even files like CAD files exported as results of computations. So that's one way, and the second way is through the Viewer API, in order to build web applications around the remote models. And a big part of the new version of Shapediver that we've been working on for a while is to expose these remote parametric algorithms in other contexts than just a web application. And in particular, so as I have a quick overview here, through other software packages like Revit and Illustrator, for example, that are used by designers and architects. Also in AR, VR environments, for example, but really there's not really any limit, especially with the new APIs and SDKs that we've developed with this update. the idea is to really make these tools accessible anywhere and integrate workflows. So instead of asking people to come to Grasshopper, the motto is really that Grasshopper will come to you, right? So, and you'll be able to access the power of parametric designs without leaving the environment, the design or work environments that you are used to in everyday life at work. So I just had a quick look, like teaser of how the new platform will look like, more or less. So if you are familiar again with our old platform, you'll see that cosmetically it's very different, but also one of the aspects I wanted to underline here with this screen is this possibility of sharing with users. So it's just one of the very multiple ways where all the new features have an emphasis on collaboration, with members of your team or outside of your team, with partners, clients, colleagues, managers, and really be able to control who can do what with your models, who can access them, monitor who accesses them, really have this management for and storage space for the parametric tools in your company. So what we'll talk about today is the Rhino client, especially because that's the most advanced part of everything we're doing. But keep in mind that all the concepts that we're reviewing today are really applicable to any other clients that will come in the next few weeks as the big update of Shapediver. And we will already have a teaser of some of these other clients. But essentially, so what is the Rhino client? And the Rhino client, because yesterday I did not really explain that very well, the Rhino client is what I sent you. So I sent you a really alpha release of the Rhino client, which you can install as a plugin inside Rhino. And the Rhino client has its standalone interface. You can launch it by typing Shapediver in the command line. And it's really its standalone interface that lets you access the list of tools, so the list of parametric algorithms that you've uploaded to Shapediver, and to open them and interact with them from inside Rhino, right? So it's completely detached from Grasshopper. It's not, I will let people in, excuse me. It's not at all, relying on definitions that you have stored locally. It's really an interface that calls the cloud algorithms that you have uploaded, and lets you control input, sliders, etc. But also, and that's one of the new things in this update, lets you reference geometry and objects from your active Rhino document and bake back the results inside Rhino. So we'll see how these workflows can be put in place using the Rhino clients. And I will essentially, this is like a semi-interactive workshop. I'll act as the Grasshopper expert, which I'm really not, but as a Grasshopper expert in the company, I'm going to be the one uploading models. And since you have access to the Rhino client, you'll be able to see after I upload them, directly access them, be able to open them and interact with them. So I think anyways, like a hands-on live demonstration is better than 1,000 words. So let's get started, and we can come back to the presentation at a point and look at a bit more technical details of what we've implemented. Okay, so as I was saying, there's really two parts of for the new Shapediver tools that we've developed. There's the authoring part, so the part where I will be able to use a plugin inside Grasshopper, a Shapediver plugin, to build online applications, online apps from a Grasshopper definition and upload them. And then there's a part which is the consumer part of the new set of tools, where you can consume the apps that have been uploaded. So in order to demonstrate all of this, we're going to look at a couple of very simple definitions, which should give everyone a good idea of what's going on here. So the first one, if you've also been familiar with Swarm, you might know this one, because I just pulled it from there. It was downloadable on Swarm. It's this simple like twisted tower generator where you can control a very schematic tower, some sizing, height, the angle of twisting the tower, and apply a set of panels on the facades. And the definition also contains a quick check of how planar each of the panels are and how far they are from being planar, and applies mesh colors to each of the panels. So each of the panels here is a separate mesh, and there's a gradient according to the value of a unitized value of the measure of planarity for each panel. So let's say now that I want to make other people in my team be able to access this tool in order to do some quick check of some quick early sketches. So let's say it's an early design phase, and see if they can generate an interesting shape with a minimal value for the planarity measure for all these panels. So the first thing I'll do in order to create this app is use some of the new components that we have. So if you're familiar with the Shapediver plugin, there's a big update coming, and here is already a preview of this update. And it works a bit differently from what you're used to. The first big change is that the Grasshopper plugin comes with an editor, which I can use to publish my apps. So I'm going to log into it with the login information that I gave you. And here it tells me, please start by adding Shapediver components to the canvas. And essentially, what this tool here, which has a work in progress name, we call it the IDE, but it's like the app builder if you want, is that as you build your app and as you define inputs and outputs, it's going to populate them and let you already define what the scope of the app, the inputs, outputs, and also the name. So I can here call it tower generator, description, and a lot of the settings of the cloud applications uploaded on Shapediver that you also might be familiar with if you use the previous version. But yeah, here the main two new components are those. Instead of just parsing blindly all the sliders and all the inputs and see what's displayed in Grasshopper, we allow users now to curate what you want to expose as part of the online app. So let's say here I want to expose a few of these inputs. So the sizing, so X, Y, the height of the tower, and the angle. And let's say that's all, right? I have this parameter here. I'll keep it internal. I don't want to expose it. Here you can see as I do that, as I work in Grasshopper, the app builder here is populated by all the parameters I'm adding. So all the inputs here I'm adding. It also lets you define. So here, for example, I can define a description which can be used. We will see how everything is built in a generic way, and each client, because there's a lot of clients, the web browser, the Rhino client, and a lot of new ones, each client will have the option to interpret the contents of the app in their own way, essentially. That's what's interesting here, because it allows us to build generic tools that can be used in a lot of different environments. So here I have my inputs, and on the other side, I want to just output my set of panels. I keep doing this mistake. So the outputs of a Shapediver app needs to be typed. So here I need to tell the app that what I have is a set of mesh outputs. So, and here now I can see it listed as output with all these buttons, which we'll see basically are a preview of how it's going to look like in the client. Here, let's say that this is all I want to do in this first version of this app, and I can now upload it. And that's also the last new thing that is part of this new workflow, is that I can just upload. I don't have to log into the web browser platform and upload my file and set it up there, I can directly upload the app that I created from here, and it's already going to be accessible through any client that I allowed it to access. Unfortunately, it worked like a charm for a few weeks, and of course, right before the workshop, it stopped working. So right now, I have an issue uploading directly from the new clients, but I can still do it here on the old platform. So this is really, as you can see, so I have to log in again. This is the old platform, as some of you might know it, and I'm going to use it to upload the app directly there. And you'll have to take my word for it that this will not be needed. Uploads can happen directly from Grasshopper. So I will upload the app. So pick the file, the Grasshopper file that I just created, and essentially everything we've seen in the app builder is included as part of the Grasshopper file, right? So all of this is already in there. So I can publish the app, and I should see exactly the inputs and outputs I defined in Grasshopper. So the four sliders, and as outputs here, as visual outputs, the panels that I've defined in the definition. I also, so that's another version of this file I created. So I also had like the skeleton of the building as part of the outputs. I'll apply the settings, which will effectively publish the app to Shapediver. And now, immediately, you should be able to access the app through the client if you manage to install it correctly. I hope most of you did. So you can see it listed here, and I can open it. So I can actually close Grasshopper right now, because really, to really just emphasize that Grasshopper is not needed to run in the background in order to access these apps. Oh, and I think I forgot to do something. So you probably had the same error as me if you try to, okay. All right, that's a technical detail. I need to allow backend access, but that will be, of course, automatic. And now I should be able to open my app, right? And I see, so what I expected, all the parameters I defined, I can change the size, the height of my building, maybe twist it a bit less, and compute, launch a computation. And I get a bit similar to what you get with in Grasshopper. I get a preview here of the computation result, and I can bake my results from here. So for example, I see I have 244 panels of type mesh. I can bake them in a document, and they are here. Right. So, and again, this is not relying at all on the local version of this file that I have. It's really something that is available to anyone that has access to the Shapediver online model. Okay, they managed to join, so perfect. No, someone else? Yes. Okay. Right. So that's about like the first. Let's say quick introduction to what the new tools, new Shapediver tools allow to do. So now let's say that I want to I want to take this a bit further. I want to have this quick this tool. I want to pair it with maybe some design to fabrication workflow, where let's say we're further down the project. We decided on a building. We have the final version of the panels, let's say, that we want to lay out on the building, and I want to create some sort of production file where I create a layout with all the panels flattened, and maybe like a note on like the planarity factor for each panel, right? So again, this is something very simple. I'll leave to your imagination how to take this a bit further. I'm neither a Grasshopper expert nor an architect, but I think that's a context where it makes sense as a prototype. So so what I can do is just start from this same definition, and I can take it further, right? I can now add components and take those panels and you know, flatten them in the XY plane. I can take my create text tags maybe for each of the planarity values and export them as a DXF file or whatever. And I could do all of this here, but here, if I do that and I upload that to Shapediver, we have a good tool that does a lot of things, but is very specific, right? Which can be sometimes what you want. But one of the aspects of all the automation and collaboration workflows that we think is interesting is to work a bit more modular, right? And really keep the apps that are uploaded to Shapediver as like very unit tools that can be used in the context of what we want to do currently, but will also apply in different contexts and can be reused by the team to automate repetitive tasks and, you know, save time, not only for this one project, but over the course of the project cycle of the company. So if I want to do that, what I can do is just create a second Grasshopper definition and upload it to Shapediver as well. Of course, what I will need is to be able to send, you know, what I have as outputs of this definition to this second Grasshopper definition that I create, right? So in other words, chain the two applications together, right? And here, what I have currently is that I only sent the meshes, so all of these panels. So first of all, I'm going to need a way to you know, use these panels as input of the second step of my workflow. But also, I need to access you know, this planarity factor, right? So this data that I also want to use to build my second algorithm, let's say. And in order to do that, I could, so I'll show in a minute, and I'll go a bit more in technical details how data will transfer from one app to another, and also from the apps to each client, right? And how they're interpreted in clients. But you can already sense that essentially what I'll do is use the outputs of this one app and use them as inputs of another app, essentially. Which means that I also somehow need to extract, you know, send this data that I want for my second algorithm. And I can do that in several ways. I mean, really, the outputs of a Shapediver inputs and outputs of a Shapediver application can be really any type that exists in Grasshopper, almost, not all, but almost. So if here I want to send, you know, alongside my list of meshes, I want to send a list of numbers. I can do that, and I can already see here it's prefilled with what I already have as default in this definition. So that's one way to do it. But of course, that won't really. I mean, that's not really going to be convenient in a workflow where, for example, the people that are going to use my apps are working in Rhino or even Revit or whatever, because they'll need a way to extract this information, right? So if I'm in Rhino, I can easily bake meshes, but baking this number or copying this list of numbers is not the most convenient way for me to then, you know, have all this data ready and use it in a different context, the context of another app. So a better way to do this, as I'm sure some of you have already thought or already work in Rhino, is to, you know, attach user text, for example. So each panel has a user text attached to it, and then it's stored. So it's it becomes enriched geometry, right? And Rhino stores this metadata as user text. I mean, there's other types of metadata in geometry, but user text is usually what you want, what you use if you want to store some numerical value for each panel, let's say. But of course, other clients, let's say the web browser, Revit, Illustrator, they can store metadata in very different ways too, right? So what we want here is that in Grasshopper, we have a quite generic way to store metadata, which we call attributes in the new plugin, and I'll show you in a minute. And these attributes will attach them to the objects we manipulate in Grasshopper and send them as outputs of an app, right? And then these attributes, essentially, all the clients will know how to read those attributes and what to do with them. So, for example, what we chose to do in Rhino is to map attributes to user text key value pairs, so that you can, because a lot of people use this and it makes workflows natural and easy between Rhino and the online parametric tool. But we might choose to map attributes to different types of metadata in other clients. So here I can show you how. So essentially, we have pretty simple new components that allow you to construct attributes and inject them in geometry. So essentially, here it's quite straightforward. I have my meshes. Sorry, that's not what I want. I have my meshes. I want to inject attributes in those meshes. So I use my inject attributes component. And what I need is to inject an attribute object here, which we have as a floating param that we added in Grasshopper. But essentially, constructing an attribute object can be done using this component. And here I can just send a list of key value pairs, so something pretty straightforward. And in my case, what I want is to send attributes that are called, for example, deviation, because essentially this number measures the deviation from a planar panel, and send those values here. So I just have to pay attention to my data structure here. Here I have a tree, and I need these values to follow the same pattern. So here I just have a list. So I'll just flatten this graph here. So I have a simple tree. And so here, if I don't graph, essentially, I'm just going to have one attribute object with a key called deviation, and that as a value has a list of numbers, right, as one value. So instead, what I want is to graph here at this level in order to create a single attribute object that maps to the meshes I have. And here, that's essentially what I do. For each of these meshes, so each of this panel, I attach an attribute called deviation with the value of deviation for this panel, right? So it is exactly what I wanted, and I don't need a number output. So actually, I think I cheated a bit here, because the one that I uploaded earlier was already my final file, which more or less matches what I have now, but I'll open it just. Some breakpoints, errors, traditional. And yeah, so here we can see that's essentially what I did. Yeah, I was a bit cleaner here. I called my panels panel, and as we saw, I also had my building skeleton as part of the outputs. Otherwise, this is the same definition. And that's the one I already uploaded. So now if I close Grasshopper again and open app, let's say I'm going to request a computation again, build the panels, and with the attributes I constructed inside Grasshopper here, I can check for any panel here. I can get the user text in Rhino, and I'll find one attribute called deviation with the deviation for this panel. So now I essentially have, from my app, I have a set of geometry with enriched geometry that I can easily use, that is self-contained and can easily be used for the next step I wanted to do, which is to create a layout with those panels, with the numbers, etc. So I can start trying to do that. And the way we do that, so now it's where I can, sorry, I wanted to Grasshopper. That's where I can start talking about essentially how data is transferred to and from the Shapediver online applications, and then back to each client that is going to consume the application. And in order to do that, we created this new file transfer format, which we call SDTF, structured data transfer format. But really the working name for it was Shapediver transfer format, and we made it a bit more generic because it is a very generic and we think useful data transfer format that can be used in a lot of different contexts. It's inspired by GLTF, if you're familiar with it, and I'll mention GLTF again a bit later. But it's a structured way to store, a lot of different data types, pretty much, all or almost all the data types that Grasshopper has. So geometry data types, but also, numbers, strings, more traditional ones. And to keep a data structure attached to them. So in particular, when it comes from Grasshopper, the list and tree hierarchy is preserved in this file. So here, what we have, and what started as like it was more of a debug tool, was the ability to actually create on the fly here those SDTF files, so containing this data transfer format, and check what's in the format. But it is actually also a very convenient way to to work locally on your apps if you work on Shapediver, because essentially now I can I have my first app. I'm happy with the way it works. I can set parameters, specific parameters, and get a specific result from my app. I'm gonna close the client because okay, I have the preview from the client as well now. So here, for example, I have a smaller, less twisted tower, and now I can go to the output here and save the SDTF file. So that's the one I created yesterday. I'm gonna overwrite it. And this SDTF file now, if I create a new document and start working on a new app, I can pull it, and it's gonna re-instantiate exactly what the outputs, so everything that was contained as outputs of my other Shapediver definition. So here, if I start working on a new app and I start with a set of inputs, I'm gonna close the other ones. Okay. I can right-click on my Shapediver input component and say, okay, please load an SDTF file that I saved. And I'm loading the one that I just created. And you can see that it parsed everything and imported it as a native structured Grasshopper parameter, essentially, right? So I have all my meshes. And I can also see that it's not just meshes, it's an enriched type of meshes that is part of the Shapediver plugin. So if I use the mirror components here of the attributes I showed earlier, I can extract attributes from these panels. And if I deconstruct them, I'm going to see which keys and values are stored in them. And I can check that I have, for each mesh, I have a deviation attribute and with the correct value assigned to it. Everything is 0.5. Okay. I'm not sure if I did something wrong. Let me open again the previous one. What do we have here? Okay. Oh no, wait, what happens? Okay. Craft. Okay, that should be better. So try again. Okay. And if I try to load the new file, I apologize, my laptop seems to be struggling a bit. Okay, well here, see, I had my version of the file with also the building input here, so I don't need it. I'm just going to delete it. And here, Okay, now what do I have? What's happening? 59,000 meshes. All right, something went wrong. Okay. What's going on? Oh, yeah, okay. So, that's better. All right. Sorry for that. So, final try, save as DTF. And I'll go back to the other app. That's probably why I was lagging a bit with my 59,000 meshes. So edit. Edit. Okay. That's better. And now I do have my values. Right. So just to be clear, that I consume, in this case, the Grasshopper acts as a client that consumes this SDTF file that in this case comes from my local hard drive, but is the file type that is used and goes to and from the cloud servers of Shapediver, right? So that's essentially how each output is sent to the servers, and when it comes back to any client that consumes it, all the client has to do is parse what's in there and extract everything. So now I know that I can work with the outputs of the first app I created and continue my work here essentially. So I'll skip some steps again because that's not the most important part. But here I already created a very simple definition, which takes each of these panels and projects them, flattens them like this, just in one row. So it's really not very advanced, and also writes down writes down a text for each of them. So that's what I still have to fix. Okay, so now we can just continue with what I just showed you. So I will extract the attributes from my inputs, and I can actually use the access key component here to just directly access the key called deviation, each of my objects, and it's going to give me the list of values here. And I can use that to draw my text, and now I have my layouts with each panel and a very simple way to display the planarity value of the panel. So that's essentially the second step here. And now we can go a bit further with the principle of attributes. So how to use attributes? Well, let's say now that actually I'm happy with this layout. I'm not too regarding. And I want to export. I actually want my app to export this layout. So basically, it's going to take a set of panels as input and create this layout from them. And I'd like it to already be a bit structured, right? So essentially, if we keep it simple, I'd like to add all the panels on a layer called panels in Rhino, and all the annotations in a layer called deviations, for example. And in order to do that, I'm again going to use attributes. And that's where attributes intervene in a slightly different way, right? So we have, what I showed so far is how to use attributes to map to, let's say, the native, most straightforward way to store attributes in objects, like custom attributes in objects in Rhino, which is with user text. But we also use the attribute system to map some some pretty generic attributes that are not set by users, but that are part of any Rhino object, right? So if you think of names, layers, colors, all these properties that Rhino objects can have when they're added to a document, that's what we're talking about here, right? And again, like our goal is still to make something that will be an app that will be generic and be used in a lot of different clients, right? So essentially, if I have a property called name, I'd like this property to map to whatever makes sense in the client that's going to consume my app, right? So we know that in Rhino there's object names, in Illustrator there's object names too as well. But we want to have this set of properties that maps to something native in the clients that are going to consume the app. So that's why we, on top of these custom attributes, we also have a set of reserved attributes. Sorry, I have to find my presentation. Here it is. And here, that's why I had these couple of slides with some reserved attributes. And with already like a quick overview of how it can be different between different clients. So essentially, we have here, I think that's a full list of reserved attributes we have so far, except for material, which I'll show a bit later. Name, layer, color, and we have other ones called plot weight, plot color, plot pattern, fill color, opacity, which means that if you use these, any of these, since they're reserved attributes, so if I store an attribute called name or plot color in a geometry and I set it as output of my definition, the Rhino client will not bake the object with these attributes as user text. It's going to know their reserved attributes and do something specific with them, essentially. So here, if we have a name, it's going to map to the Rhino object name. If we have a layer, which is also a string attribute, it's going to map to a layer name in the document. And if we have a color, it maps to the display color of the shaded mode in Rhino. And here we also have some other attributes that are already used in Rhino, plot weight and plot color, which are used when you want to export DXF files, for example, drawing files, which have these plot weight, plot color properties when you export them. But see, for example, we have these here, and you can see that those don't necessarily have any meaning in the context of Rhino. I mean, opacity could in the context of the materials, but we'll see later that we have a material property that's specific to store, extract and store materials in the objects. But just to show differences, for example, in Illustrator, name and layer are pretty much used in the same way, name of objects and the layer names. But the color attribute does not map to anything specific in Illustrator, because in Illustrator, essentially all objects are path that can be have a plot color and so a stroke color, it's called, and a fill color. So we use those instead, right? So we have the plot color here, which we use to export DXF, is also used in the context of Illustrator to have a stroke color. And the fill color here, on the other hand, does so far only makes sense in the Illustrator client, but it's generic enough that if we start having clients for other software that use something that can map to fill color, then we can map it as well there. So yeah, that was a quick overview of the technical details of those attributes. So essentially, what I can do here, I think I won't do it. I won't do it manually. I'll also just go directly to my final version of this definition, which takes the so that's all the panels flattened and laid out in the XY plane, and I inject in them an attribute with the key layer and called panels. So basically, the name of the layer is going to be panels. And here I also have the frames, and here the layer for the annotation is called deviations. I inject that in all my outputs, and I then create an output object that has all these outputs. So if let me check that everything else is closed here. Okay, if I show the editor here, yeah, sometimes it does not show me everything, so I'll have to recreate. Okay, the outputs now are shown. And right, so essentially here I have an app that has as input a mesh, or potentially a list of meshes, as we'll see. In this case, I'm going to input a list of meshes. And that's something that's really new if you also knew the legacy Shapediver application. We were only able to as input, you had sliders, the toggles, the value lists, like all the standard parameter inputs in Grasshopper. But now with thanks to this data transfer format we have, which keeps the structure, and in the context of these clients that can reference geometric objects, one or several, and potentially even send them with a data structure already in them, we can have geometry as inputs, like as actual inputs of Shapediver applications. And case in point, this app has a mesh as input and as outputs, so panels as meshes, I think, frames as rectangles, and deviations as curves, because I just drew them with curves. And so that's my app. So I can give it a name, etc., and upload it from here, which again, today, especially because I had a demo, I guess, stopped working. So I'm gonna again do it from the online platform. Here we go, upload. Layout final. I forgot the backend access again. I have to remember that. And here we can see also that to extend the discussion I had with attributes, the input and output, and especially now that we have these really specific inputs, for example, mesh as input. What does it mean to input a mesh in the context of various clients, right? There's no meshes in Illustrator, so the meshes in Illustrator, you won't be able to set a mesh as input in Illustrator. These inputs will be hidden if you try to access them in the application. In some cases, there's like smart ways to map types to each other, right? So, for example, in Illustrator, everything is path, which is essentially more or less NURBS curves. If I have outputs in my definition, if some of the outputs in my definition are, for example, rectangles or circles, well, there's no native rectangle and circle type in Illustrator, but we can just cast them. It's very obvious to cast them to curves and bake them as curves in Illustrator, right? So each client will interpret differently the inputs and outputs that are in a definition. And here, for example, you can see that our legacy platform, because it had none of this, it does not know what to do with those with the mesh inputs, because what does it mean to input a mesh in the web browser, right? The new platform will let you input meshes. Of course, you can't reference a mesh in your document. You don't have a Rhino document open, but the mesh input will let you, for example, upload any file, any CAD file supported by Rhino, and extract all the meshes from them and use them as input of the definition. That's one way, right? So this is really a strategy that depends on the clients. But on the legacy platform, since I'm really using all the new concepts of Shapediver, the legacy platform is a bit lost here, and it doesn't show anything, and it doesn't show me any inputs. So I just remembered that I forgot to allow backend access, which is what I need to open the model in the client. And now, if I go back, I'm going to close Grasshopper. And I should have listed the app I just uploaded now, called Layouts. So let's try our complete workflow now. If I go here, I'm going to open the tower generator once again. I'm going to bake a tower. So here I could also have had, instead of like this, for example, this X, Y size, I could just have add as input a rectangle, right? And just let people define a rectangle in the document and use it as the base for this tower. Okay, I'm gonna bake this. Oh, that was already done. Okay, my panels. All right, now I have all these panels. Again, they have, if I check them, they double checking, they have deviation part 0.5. I'm gonna check they are not all 0.5. I think I still have the bug that or well, it's not a bug, it's a Grasshopper error that I had when I uploaded the file. But okay, I won't re-upload it, so they're all going to be 0.5. That's not an issue. You get the picture. So here I can now, I have my mesh input in this app. I can select all my meshes, set them as input. I see now they're internalized. I can do my computation. And here I have already my preview of the layout I created. And now if I bake things, so let's say here I have properties. So if the layer already exists, it's going to use it. If it doesn't, it creates it, right? So I can bake the deviations, and it creates a new layer called deviations, and it stores all my deviations in this layer. That did not seem to work. Let me try the panels. Yeah. All right, and so I successfully managed to create two pretty units, like pretty simple apps, and to integrate them both in a single workflow, essentially. And that's, you know, again, might be, I mean, we can already see how in the context of a company that's going to reuse and redo the same repetitive tasks over like lots of projects, that's useful. But I did everything in Rhino today, right? So so it's not, it's maybe not super obvious how the collaboration, how helpful it is for collaboration. But obviously here there's apps that are going to make more sense in the context of Revit or other clients, right? So you really have, you can have parts, you can have a collaborative workflow over different clients and send data back and forth between different members of a team. Which I'm going to give more details on that. It's the upcoming features, but it's all about sharing apps, sharing saved states, so sets of parameters of each app between different clients and between different people in the company, be able to open them and continue working on them. And all of that, you know, without really having to like send files back and forth, and also not having to learn or start, you know, using a set of different tools, but staying in the tools that you use the most, right? So that's also productivity optimization. So yeah, so to give a better idea of this like cross client workflows, here the last app I had that I already had uploaded before the workshop, and that you might have had the opportunity to play with already, is an app that is very simple, takes a curve as input. So for example, this curve, closed, I think it should work with a non-closed curve, but the point is to use it with a closed curve, and you know, just populate it with a Voronoi pattern. So here I select this curve as input. Now I can see it's internalized. So that's like the colors we have for the previews so far in the client, right? It's this pink for the internalized inputs, and when you bake things, it's this blue, light blue for the outputs. I can define a number of cells. 5, bake. I'm going to preview my set of curves. And I can bake them. And so here, that's a modest contribution to the design world, of course. But if I look in the definition of this file, if I find it, yeah, okay. What I do in this file, and I mean, I could do something similar with the materials inside Rhino and Grasshopper. But here I just made it, let's say I just made it compatible with Illustrator if you want. So what I do actually with all of these curves is that I store an attribute, I store a set of attributes, plot color, plot weight, plot pattern, fill color, opacity. But in practice here, the only one that varies from one curve to the other is the fill color, right? So, and I created this, like I used Pufferfish to create this twin between two colors, and I randomly assign, a twin color to each of the elements to create a pattern. And I injected these attributes, and my output is all these cells, which are curves with enriched metadata, and especially the fill color, which is what interests us here. And so here, I'm not going to show you live because it's on a different development branch right now, so I don't want to risk going back and forth too much. But I can show you a video I recorded a few days ago, which, I worked on this, and it worked really well. And hello, I'm Mathieu from Shapediver. Well, I'm not going to play the entire video because I run you through how the definition was built, right? But here you can see that I set my set of curves and my slider as a number of cells as inputs. Here I'm going to describe how I attach all the attributes, and here you have the proof that a few days ago the upload worked. So I'm uploading from the client, and after a few seconds you get a confirmation that your model has been uploaded. And now I can close Rhino, Grasshopper. I don't need Rhino, Grasshopper. Again, it completely relies on the cloud, on a definition stored in the cloud, right? So I can close everything, and we have this standalone client that is not even linked to Rhino at all. It's this standalone Windows application that you can use the Illustrator connector with. So here, I'm already setting the communication between the client and Illustrator. And so here it's in my personal account, so there's a lot of apps, but this same app that we just reviewed, the boundary Verona app, is there. And then I can really interact with my Illustrator document, right? So I can create a path like this and set this path as input. So it's gonna, as I was mentioning, convert this path to like a native SDTF type, right? So that can be read by Grasshopper. I set the number of cells. I send the compute, and I can see that I received 65 curves, right? Which again, I'll bake and convert to a native Illustrator type. And all these curves are essentially just paths in Illustrator that correspond to my cells. And Illustrator read the attributes that I stored in each of these curves. And especially the one I stored is that there's no stroke for all the curves, and there's a fill color that is different for each of the curves. So I really have this workflow built in Illustrator to use an app, and essentially I can use it even if I've never heard of Grasshopper in my life. So that was just to have a quick detour and give you more of a sneak peek of what other clients and what workflows using other clients can look like. Essentially, it will always also be possible to share saved states, right? So let's say I could have someone. Let's say Illustrator is actually limited in the sense of like the curve, the curve topology that you can create. That's not true. You can do a lot of curves in Illustrator, but that's for the sake of the argument. I could just open, someone else or me, if I know how to use Rhino, I could just open the app in Rhino, create a curve in Rhino that is, that fits what I see, and save it in a state, right? And share this state with my Illustrator colleague or whatever. And in that case, you would already have the curve internalized as input and not have to input it from Illustrator, and can bake the results in Illustrator. So that's another example. So we're pretty advanced in terms of attributes now, but I'd like to show the last way, so the last reserved attribute, which I've mentioned a few times, which is the material attribute. So essentially, it's possible to store materials inside the geometry that are in SDTF, so the geometry that goes in and out of Shapediver apps. And the way we store this material is essentially it's our own Shapediver material representation. We can see the complete representation here, and it's not very idiosyncratic. It's just essentially maps in a pretty straightforward way to the material attributes of GLTF2 files. GLTF2 files are really the standard files that are used by most of the WebGL viewers online to read and display geometry online, right? And the GLTF file format is more and more relevant. It has even like some limited support in several desktop applications. So, for example, I think in Maya you can export your designs as GLTF and just open them in a web browser afterwards. So that's why we have this material representation, right? And historically, this representation we've always had to convert it back and forth with the Rhino material representation, because up until Rhino 6, Rhino only had specular diffuse representation for materials. So that we can see with the create material component. If you've ever used this one, you can have a diffuse, specular, emissive color, and it's not always super straightforward how to map one with the other, especially because well, this is a more limited representation for the materials. So here what we have is that in this new version of the plugin, we extended a bit those components, our material and display components, and we are able to essentially map these different types of materials. So I can create, for example, a Grasshopper material, or even import one. So if I have an object from a Rhino document as input, I'm gonna import it with its material, with the Rhino representation, and I can convert it automatically, like cast it to a Shapediver representation, and we do like a the best possible mapping that is available to do that, right? And it's possible in both directions. Fortunately, in Rhino 7, there's support for PBR materials now, so we'll be able to improve this and have a more closer mapping between materials in Rhino and materials in the Shapediver plugin. But okay, so I can create. So let's say here I had my. I'll do it again in the. In the tower generator here. Just have to check. Is that the good version? Yeah, I think that's it. Okay. So here I had, so the way I did it is that I used mesh colors, right, which are supported both online and in the Rhino client and everything. But let's say I want to do something a bit more advanced, and instead of having object with mesh colors, what I want is to store a material in the objects. Well, the way I'll do this is a bit similar to what we've seen with the other types of attributes. I will take my meshes here, and instead of doing this, I will inject attributes. And in my case, what I want to inject is a material, and material casts to Shapediver attributes. So I can create an advanced material, for example, and okay, I'm always, oh yeah, no, I have to construct an attribute using a material, yes. That's how it works. And set it as attributes. And what I want is to, so this is I don't remember if it's a list access. Let's see. I'm going to create a material with a different color for each right? So I create a one material per color I want to use here, and same as I did, I have to graft it, otherwise it creates one attribute. Graft simplify, and same here. No, sorry. That seems to work. Okay, that's not. I could do this a bit more clean and add all the attributes at the same time, but anyways, I then add my deviation attribute, which is a second attribute, and I have my preview here. And I think that's what I realized here. The preview did not work, but if I bake, okay, so not here. Let me try that. So yesterday it worked. Interestingly, I can't bake from here. Okay, let me try to save the SDTF. I think we are good here. Yes, okay. Here, so I don't have mesh colors anymore, right? So here I have my preview, and this preview is using the materials I stored inside the objects. So here, if I use all the extract attributes, I'm gonna find, and actually I can also just, no, we don't have the extract material component yet, but okay, I can extract attributes and look for the material, and I'll see all my material properties. But so here I just send the color, but of course I can do a lot here, and I think what's really on top of what's available in Grasshopper natively is that here we have access to all the maps of the PBR material. So I can send a texture, a color texture, metalness, roughness, texture, opacity, normal. So all the standard maps for PBR materials can be stored inside the object. And the final thing that makes all of this, and including this material support inside SDTF, is that we have the corresponding. We actually also generate from these input and output components the GLTF file, right? And as I was saying, the GLTF is the standard format online to like display geometry online in WebGL. And that's the format that then if you upload your Shapediver, your Grasshopper definition to Shapediver, essentially our servers will generate all these outputs that are used in the client, and also a GLTF file that is used for visualization online, right? And here we also have a tool to directly, for testing and debugging purposes, allows you to save the GLTF file locally. So essentially, it becomes at the same time the first GLTF export tool in Rhino, because Rhino does not support it yet. I expect that it will, not in the not so distant future, but right now it doesn't. So I created this GLB file, and actually, so GLB is just a name for binary GLTF files. And actually, this is pretty cool because that's a file that really can be opened in a lot of different viewers and integrated. So essentially that's also what makes Shapediver compatible with other viewers. If you already have applications or websites or whatever that use a standard viewer that's compatible with GLTF2, then you can use Shapediver and completely forget our viewer and just use yours if you have some specific shaders or specific tools in your viewer. And this can be seen very easily even in Windows, because Windows, I think it's from Windows 10. So if you don't have Windows 10, don't worry that you can't open these files. But Windows 10 has an app called 3D Viewer that lets you visualize GLTF2 files, right? So this is really files that can be visualized anywhere. But I can also drag and drop this file in like online viewers, and it will be completely supported there. Yeah, so that was about materials and how we handle them. I think that's more or less everything I wanted to show as part of like the new workflows that are possible. And oh yeah, no, let's look at the one last point before I go back and finish the presentation. I think we still have some time. Yeah. So the last thing I mean, there's a lot of things. If you're familiar with Shapediver, you know there's a lot of tools that you can use or in the plugin. You know, we have this whole bitmap parameter that we added that lets you manipulate bitmaps and you know even use the Squid plugin to create vector files and all of this. And we also have support for PDFs, like create and export PDF drawings and things like this. But okay, this workshop is not really about this, and there's a lot of documentation about all of this. But what I'd like to just also quickly introduce is the updated versions of the import and export functionalities of the plugin. So this is the, you know, on top of all the traditional inputs and outputs that we've seen during the workshop so far, you can also work importing and exporting files, right? So locally, but also online, right? So in the web browser, the web browser lets users, if you use these components, you can let users upload a bitmap file, a geometry file, a text file, and download, and at the other end, download a completely already formatted CAD file, and there's a lot of different ones that we support. And actually, in the legacy version, we did not support so many because we had to build our own import and export tools because Rhino did not let you do that headless, right? Like do these imports without the import and export interfaces that use the Rhino UI. But of course, with Rhino 7 comes Rhino Compute, and all of these functionalities can be accessed headless now, which means that the new Shapediver import components virtually support any file format that is compatible with Rhino. So if I double click here, that's a list, right? But it maps exactly or not exactly, but pretty closely with the list of files here that are available, of file formats. So, and you know, this is also compatible. There's a way, essentially, since these headless import and export tools of Rhino, essentially what they do is, you know, they already have a strategy to import external formats and turn them into a Rhino document, right? So, and you have this headless Rhino document where you can access all the geometry the same way we do in the active document, right? So whatever file format you're going to import, essentially what you're going to get is going to come in the same formatting as any other input that is used here. So essentially, if I try to bake this, so will it work now? Yes or no? Okay, there's still a problem with the bake here. So I have to bake those directly. That should work. I'll check that the material is there. No, okay. Compute. No, oh, wait. I think that's also something that worked yesterday, so I'm a bit confused. But okay, I'll try to go here. Yeah, okay. I'm not sure exactly. So I'm supposed to have the material in the file, but I don't right now. That's not an issue. I can still bake all of these panels and save them in so let's say a 3DM file. Yeah, I did yesterday, and now I can. So these imports, what's good also, it's like for debugging purposes, but it's compatible both with like an online URL or uploading a file format directly online, but also with local paths, so you can test locally. So here, if I reference my panels.3dm file that I just created, I will import all these meshes. And importantly, I will import them with their attributes, right? So here, since I didn't really set any, if the material is not in there, I'm not sure what I'll get. I could extract all of those. I expect some will be empty because I didn't define anything. Yeah, so you get the default values because I didn't really. So default layer, the color is black. And you do have an SD material, but it's the same everywhere. So yeah. So the same workflows are going to be available, working with those files. Just like on the other side, in the side of exporting, we used to have this. So we have this export component, Shapediver download export, yeah. And here you can set. So you used to be able to just set data, so meshes, whatever you had, and select a file format, which we had like 5, I think, 3DM, OBJ, STL, STEP, DXF, DWG, something like this. And essentially, our export component was trying to parse, okay, this is compatible with this file format or not, and a name, and that makes an actual. So even from the web browser, then you could, trigger the export and download whatever export you had. But now with our new version, so not only can you use attributes to set, to really set advanced layers, names, colors, so really format your exported drawings, for example, with the formatting that, maybe you have a standard formatting that you want to follow. But also we have more types, and we support a lot of export options. So let's say if you want to export so the drawing export options, for example, now we support all of those, which used to be an issue because we could export DXF, but if you don't set people, how to export lines, arcs, polylines, splines, etc., then you end up with files where you can't really control depending on which CNC machine is gonna cut the file, for example. So that was essentially an obstacle to complete automation. But now you can really say, okay, I want to export all of this geometry, and I want to export, lines as whatever, all the standard DXF and DWG export properties. So yeah, that's the last big update that we had, that we added to the new version of the plugin. Okay, so essentially, I think I showed everything now, and what I can do is just quickly get back to. So I talked about those. I can quickly get back to the presentation, and talk a bit about what's next. So the big picture of what's next, right? So what I showed today was a bit of cheating, and you've seen it. There was a bit of cheating in the uploads and some of the features. But essentially, we're really close to releasing what you've seen today. It's going to be a matter of weeks. But of course, the main cheating that we did today is that I gave you all the same credentials to log in a Shapediver account, which was the same that I was using to upload the files. so that everyone could look at the same files together. But obviously, what's going to be really interesting in terms of the new features is the ability to work with your team, right? So to have different Shapediver users that can safely, so in a secure way, share apps with each other. And without having to send Grasshopper files and to have to remember which one, and to make sure that you have the same plugins installed, and all of these all of these problems that come with working with Grasshopper, and to also share, but with a certain level of permission, right? So you be able to share, but only for consuming, or you can let people export, or you can let people only open in the web browser, but not in specific clients. So have a lot of control over what type of permissions you give to other members of your team, or even, so if it's people outside of your team, if you want to show someone something to a client or a partner, or where you have to be a bit more careful with how much you show and how much you share. And with the sharing, what will come is the saved states, right? So this ability that I mentioned a bit earlier in a specific use case to really take a snapshot of your of the app at a certain moment and share this snapshot as well. So not just sharing the apps, but sharing snapshots, and be able to work on design iterations in a team environment. Here I should revert those two because in terms of priority, of course, after the Rhino and the Illustrator client that are 90% there, other clients are on the table, and the first two that seem to have a lot of traction amongst our existing users, but also a lot of people we talk with, are obviously Revit, which, as you might know, Swarm had a prototype of a Revit client, and here we really we're in an intense phase of communicating with the community and with the Revit users and Grasshopper users, and try to get a better sense of what makes sense and how to envision workflows between the client and Revit. And we're happy to discuss with anyone who's interested in that, because we just started, and there's really a lot of leeway to influence the design decisions here. And SketchUp is obviously also used heavily in the AEC and other industries, so it's really interesting for us, and with potentially more obvious mappings of data types between SketchUp and Rhino. But of course, we welcome any other client suggestions that would make sense, in the workflows of anyone in the community. And versioning here that I put in the middle, but really should be, it's going to take more time. But here, that's really the vision that, starting from the fact that working, collaborating, more than collaborating, as we've discussed previously in the workshop, but collaborating on a Grasshopper definition, on a parametric algorithm. Grasshopper does not make that easy, right? Like, you really have to make sure you have the same setup. You really have to send files back and forth and all of this, and it can become a mess really fast. But we really think that there's a potential for Grasshopper to become, to work together on Grasshopper tools. And as such, it's really important for us to try and give the type of tools that essentially developers use to version their code, right? So this type of GitHub, like repository type of tools. And here, this versioning, there's going to be several steps. The first version will be that you can just update, push a new version essentially of the app, which is interesting for anyone who is using it in your company, right? So let's say you want to push a fix, you want to push an optimization, more features to the Shapediver app, you can do it. And when you decide, deploy it, and everyone using the clients will have a way to do it, right? So it's a really interesting way to deploy tools painlessly throughout a team and beyond, potentially. But obviously, versioning gets even more interesting if we have this ability to push, right? So going back to the GitHub type of workflows, to pull. So to pull back a version that was pushed to the cloud, right? And be able to keep working on it and maybe push a new version from there, right? And that's really how you can allow asynchronous work between different people on a single Grasshopper definition. So that's also the next big step we'd like to reach. And that sums up pretty much everything I wanted to show. And I offered Q&A throughout the session, and it did not really happen. So I think it's good that we have half an hour now, because we can then go back to a more conversational part of the workshop if you're interested in that. But most of all, thank you for sticking with me for an hour and a half. If you need a glass of water, please get one. And yeah, I'm happy to discuss with everyone now. So do we have any questions?
Yes, there is a question in the chat. When do you plan to support BoolAnt?
Oh, that's a very specific question. I think we do. So I don't know if so. BoolAnt is the free plugin released by John Merchant.
Geometry Gym.
Yeah, so it can be used in conjunction with Geometry Gym. So we have a specific set of servers that basically we're trying to see how to work with all the developers that have licensing and potentially paid licensing system for their tools. So we have a set of servers with Geometry Gym that you can use with Shapediver, right? So we have I can send links, but we have a lot of examples of importing and exporting AFC files to a Shapediver application. And I think on this, so unfortunately, I think it's only on these servers that BoolAnt is released, because I think it is part of Geometry Gym natively. So it is there definitely. But I have to check with the team. I don't think we have released BoolAnt as part of the shared system that is available for everyone. And I'm not sure what's the feasibility of it, but I can double check with the team and we can try to have it. I can link maybe let me pull we have a link for the list of third-party plugins we support that I can send in the chat while we get another question. No one. So if you have also, using the Q&A interface might be a bit easier than the chat to ask questions, but really it's pretty quiet right now. So you can also just turn on your mic and camera and ask me the question directly. That works too.
Can you hear? Can you hear me? I have a
yes.
Yep.
Okay. My question is, so when you were talking about the sorry, I was just wondering, is there any thought of working with any game engines like Unity or Unreal, especially when you're talking to us about the GLB output and GLTF output? So I work with shop architects, and we are doing a lot of Unity stuff in terms of AR, VR, and mixed reality, and the GLTF export is something we're very interested in for Rhino because, I mean, you know what, but just the functionality and the lightweight and the web applications, it's all very good for us. But I mean, obviously it's not something that Rhino's always been great at. So it's cool to see that your plugin is working towards that.
Yeah. Emil, you wanna take this one?
No, sure, absolutely. I mean, we actually have, I mean, in conjunction to this new push that we've been doing with the Swarm and Shapediver merge, we've developed a new sort of SDK based on C# that you can use directly from basically any .NET environment. So we've been doing some experiments with another VR platform, but it's exactly as you say. Like you can run computes using the SDK, request the GLTF output, and then just kind of dump it into the scene. So for sure, I mean, that would actually be an interesting experiment for the hackathon. Actually, like actually see if we can
I
get some
heard that.
GLTF assets in Unity.
I heard one of the teams of the hackathon might work on something like this, right? So
right, yeah, oh, sure.
Yeah.
Well, I can't be part of the hackathon, unfortunately, but hopefully whoever's on that team is listening.
Good.
That's awesome, though. Thank you.
As a quick additional note about this, the GLTF. What's good about the GLTF exported from the Shapediver plugin actually is that they also, to some extent, preserve the hierarchy of data that's stored in Grasshopper, right? So it's actually, but it's still like a compatible. It's still standard plain compatible GLTF2. Just the hierarchy of nodes in the file respects the data in Grasshopper, so it can be interesting to use them in conjunction with other applications.
No, definitely, especially considering the attribute system. I mean, you can imagine having, that
attributes line there, right?
Actually, exactly, like matching up with the GLTF nodes, essentially. So there is some really interesting experiments to do there.
Yeah.
Yeah. Very cool. Thank you.
So anyone else? Why was today shorter than yesterday? Oh, that's because yesterday someone asked about the API and I took 20 minutes to show the API, I think. So if there's no questions, I can do that, but let's double check first if someone else wants to ask something. And I'll prepare. All right, nothing else yet. So please interrupt me because the priority is that we can discuss if you want to now. But while that happens, I will share my screen, and we can look a bit at how. I mean, essentially, it's more it's more legacy Shapediver feature, but that's maybe something that people are less aware of, especially in the context of the AEC and all the tools that we discussed now. What's really important for us is that there is a flexible API that lets people take what we're doing further, right? Because we are developing some clients, inspired by what Swarm had and what the community seems to have an appetite for. But we're not going to develop 1,000 clients for all the software that are used in this industry and others, right? Because Shapediver has users in a lot of different industries. So this whole push that we've been making was also about making sure that developers have all the tools, like very accessible tools to build their own clients, right? And that's why the SDTF file format that I insisted a lot about is part of that. The C# SDK that Emil just mentioned is part of that. Literally, with those two things, all you need to do is understand what data that comes from the clouds and is essentially a representation of what comes from Grasshopper, how to interpret that in whatever tool you want to build in whatever environment. And so in this regard, we have a lot of several APIs that are being developed. And what I'll show now is like the early version. So it's what we call the viewer API. So that's like the API that historically lets you access and interact with Grasshopper, with Shapediver apps, but right now Grasshopper models in the back through just a very simple JavaScript API. So I'll show that. And you should keep in mind that, with our new tools, I mean, we already have a backend API, but it's even more accessible and open now with the new release that we have. So this new backend API will essentially be a direct link with the servers, right? So it won't have to go through the viewer. It essentially turns a Grasshopper model into a remote API itself, right? Like a mini API that you can send requests to and get computes back from, which can be geometry or data or any of the file of the data types we support. So if we look at a Shapediver model here, I can already show some principles of how things are stored, how things work, and even how then how we build this, for example. That's the old platform, of course, but how is this 3D model loaded, and then these controls, they're created on the fly just by reading what parameters are in the application and connecting them to to server requests to update what this model looks like, right? So here, changing a style, changing several parameters like this. So what's good essentially is that the API here, the viewer API, is available directly through it's exposed through the browser console, so you can really easily demonstrate and test it also, right? Like if you upload your model, you can test and make sure that everything you wanted to include is part of your model. So there's essentially several interfaces in the API, but the first obvious one is the parameters interface. So here, if I do api.parameters.get, I will get the list of parameters that is stored in this application. In this case, there are 42, and each parameter here is represented by this JavaScript object, which tells me what type of parameters here. It's a float, right? So that's probably well, there's no slider here for some reason. It's probably this one is hidden, because you can hide parameters too. So let's pick another one. For example, this facade pattern design. Yeah, this one. So this one is a string list, which is the value list parameter type in Grasshopper, right? It's visualized by a drop down, and then I can check. Well, it has a unique ID, but I can check its name, and I see its default value. Which, in the case of value lists, you have this array of choices, and the value of the parameter, so its active value, is the index in the array. So here it's 3, it's exact. So here I have the complete description of the parameters that are stored in my model. So I can essentially, just doing that with a very simple JavaScript, I can generate HTML controls that correspond to all the parameters very easily, right? So I actually have a code pen that I can link. I'll link it in a Slack channel, I guess, because it was asked yesterday already. I have a code pen that shows how to loop through these parameters, create HTML unstyled, no CSS HTML controls, and that's also like very web development 101, let's say. And then once I have my parameters, I can essentially say, okay, now I want to update one of these parameters. So I can say API parameters.update and async, because in the API, all the asynchronous function, which don't immediately give a result, but have to call the servers and return later, have this postfix, async postfix. And here, what I want is to update a parameter called. I'm having trouble with my new German keyboard. It's like a parameter called facade pattern style. So the first one that I had here. I want to update this parameter, and I want to give it a new value, right? And as we've seen for value list, the new value is 0, 1, 2, 3, 4, right? One of these values. So let's say I want to make the building straight. So 0, 1, 2, 3, 4. So value 4. And I can send the request. And we can see that my building got updated. And here I can even see, so the promise returned, I can even catch if there's errors coming from the servers. Here, result value, okay, everything worked, I'm good. So that's the parameters interface. If we now look at what else I can do with the API, well, I can also look at everything that's in my scene. So there's a get function, api.scene.get, which lists all the geometry in my scene. And here, again, like yesterday was another model. I'm not lucky, but here I I have this model does not follow the the best practice to upload Shapediver models, because it named, so all the outputs here, they correspond to output components, right? So in the new plugin, these output components here. In the old plugins, we only had this display component, so that's why. And it used to be called SD display geometry, this component. So here, the designer left the default name for all of the output components which display something here. Ideally, if you want to keep some structure, you want to give the components a different name. Let's say like panels here, and then I have another display component that contains the glass or whatever, the floor, etc. And if you give those components a name, then they come to the API with the right name, and you can still access them. And you might wonder why you'd want to access them, but I'll show that in a minute, because sometimes you want to then do things on top of just updating parameters. You might want to manipulate the geometry directly here. So for example, let's say I want to let people, click on some things, show a color, then display something, or maybe click and then show a parameter and they can change parameter. Or I can also want to let people drag and drop elements in the 3D viewer. And here, if I want to do that, I have to give a name, right? I want to say, okay, I want to let people click on the balconies here, but if I don't have an asset called balcony, then I can't identify it, right? So that's how you communicate things to the API, essentially. So we have these essentially two interfaces, and if you have, I talked about exports earlier. If you made like file exports components in your application, you do exports.get and you get them. There's none in this model, but here that's how you would get. You would list them, and with a function called api.exports.request async, so request exports, you can trigger the download in the web browser and get download the export file, the cat file, or any file. Yeah, so essentially that's a single level, and that's how these principles will be followed by, any way you would want to interact with the Shapediver API, so through the browser or not. So if we go back to this Unity application, for example, you would probably use a backend API that does not use a 3D WebGL viewer, because that would defeat the purpose, and get back the assets here, so the outputs, and so it will look a bit different, right? So don't take it for exactly like this, but same principles again. Then you can list the assets in the scene and look at it. And here, for example, you have an output with format GLB, which is a GLTF. So since it's the old viewer, it's actually not a GLTF2 compatible file, so it's not possible here. But with the new viewer and the new plugin I showed today, all GLTF2 compatible, and you get a link for the GLTF file for these assets, this geometry that you included. So you can see how you can headless, just get those GLTF files and load them in Unity or whatever. And
yeah, while you were talking about this, I was thinking about exactly that. I mean, because we do a similar thing with how we handle assets and asset bundles through an API, but yeah, but it's a little different, and we're not at this moment using GLB and we're also not really dealing with attributes and metadata as efficiently as that. So yeah, very cool, very cool.
Yeah, but so that's exactly. So that's the way it's going to be possible with a GLTF2 support to do interesting things with the API. Right now we have the viewer API offers. Yeah, that's one example. So the viewer API. So well, that's an example essentially that is using what I just showed, right? So creating a custom user interface around a model, right? So here you have this massing model, and you can create it and even like display. So this is data that comes from the servers, and you can display them directly here. And give this tool as like a this quick exploratory tool for the exploratory phase of the project, for example. But if I go to our accounts, we can look at the some things that are a bit more interesting to do with the API. Again, interrupt me and ask me if there's any questions. And what I did not find yesterday, I wanted to, yeah, this one, the RIPS table. Okay. So here we'll make this better essentially, but here that's the parts of the API. And what I forgot to mention is that these parts of the API that I'll show now, they are just API, so they're just available to developers now. But the idea is to make that native in Grasshopper too. So to let Grasshopper designers do that directly in Grasshopper, include it in the definition, and when they upload the file, it's already available without having to use any API or any code, right? So like going from a low-code tool to a really no-code tool. And here you can already then, so it's using the API, but let's use our imagination. I can already imagine that in my Shapediver app, I define as input, with all the new types that we support, I define as input a point or list of points. Right. So that's one of my inputs, and then I have sliders. I have all the other things. And so of course, if you can upload that and access it through the Rhino clients, then in Rhino you'll have the inputs that we just showed. So you'll have those two inputs. You'll have the slider that you can move in the Rhino client, and you'll have the point, which if you select it in the interface, it's going to let you then Rhino will prompt you to select one or several points in the document. Press enter, and you've set your other input, right? And what I was mentioning earlier is like this, this asymmetry between all the clients, right? So what does it mean to have a point input in the client? Well, right now, nothing. If you upload this on the old platform, the point input would not give you anything. It could just give you, if you use a point, you could interpret it in the browser as having this input with 3 text input X, Y, Z, and you can enter a coordinate for each point, which is not super user-friendly. The last thing you can do is to try to, basically to reintroduce in the browser some CAD elements, right? So to actually have point elements that you can interact with in the 3D view, right? So here, that's what we did with some API, a bit of API work, and inputting and outputting JSON data from the Grasshopper definition. And you have this RIP table that's controlled by a simple NURBS curve, and I can move directly in the browser the points and updates the model according to the new position of the points. Obviously, the updates I'm requesting are very complex, so I don't have live updates in the browser. I have to send this update to Grasshopper and get it back. But it's pretty good, right? It's pretty close to this experience, and it will also be much faster with the new GLTF representation we have, which is much more compact than the way we store the geometry in the old viewer. So that's going to be make us closer to have this type of workflows in the viewer, right? So you can imagine now a lot of tools. So if my input is a curve, you could have like a curve, like floor plan drawing directly in the browser, these kind of things, essentially. Yeah, and I mean the last thing that I could show is how it looks simpler, but it's actually using a bit more features of the browser, of the viewer. What is it called? So still in the context of allowing this kind of direct interactions with online models. Here we have again, draggable points, but I stay in a 2D layout, and I can drag them. But I not only do I have my point that I can move, but also these curves that are defined in the Grasshopper model, right? I also override them with live elements in the viewer so that they're also live, which makes it simpler to basically make updates here. Because if the curves did not update as I move the points, it would provide a pretty poor user experience. And again, simple then regenerating. So essentially, I have this, I desynchronize I detach the transformation that are easy to do in the browser from the ones that I can't do in the browser. I can't live generate a Voronoi pattern in the browser. I could code it from scratch, but that's not the point, right? So here I just regenerate what I need Grasshopper for, essentially, and the rest is here in the browser. All right, I think that's it on my side. So we have 5 minutes. I'll again welcome any other questions you have. Otherwise, I'll thank you again all for coming. It was great to talk with you about this. I think I invited you all to the Slack channel. So if questions come later, you can also use the Slack channel to ask them and to brainstorm and discuss about various things that are interesting for you. And yeah, I look forward to seeing you again in another event. Oh, I see a question. Is there a way to integrate in Flask Python? Well, that's where my development background is a bit limited, because I have no idea what Flask is. But Python, yeah, I mean, yeah, we don't have a Python SDK already built, but it's possible to create one for sure. Sergey, you unmuted yourself for a second, so maybe you had a comment.
I consider trying to tease that out. So yeah, Flask is basically a server, like a Python server package.
Oh, it's like Node.js for JavaScript, or?
Yeah. So I mean, I imagine that if there's a JavaScript API, obviously for Shapediver, so if you could format all of your input DTOs in the proper manner, I don't see why you wouldn't be able to talk to Shapediver from Python.
Yeah, exactly. Yeah. No, there's no reason. Did I miss any question before that? No, not so much. Okay. Well, then I think we can call it today. Thanks everyone again. That was great. And yeah, huge thanks to Core Studio, both for organizing the event, but first and foremost to have been with us in the past year to develop this tool. Sergey and Emil here have been really instrumental in bringing this to life. So it's been really amazing working with them. So
thank you. Work, you know whom to blame.
yeah. Now you can publicly be shamed for things that.
You've all the bugs that we saw in the workshop, exactly.
No, I think it's pretty light on bugs. I'm already pretty proud to be showing this tool to people. So it's great. All right, then. Thanks again, everyone, and have a good day and enjoy the rest of the event. If you're in the hackathon or the presentation, there's a Shapediver presentation on Monday too. Should be interesting. So yeah, see you.